Okay, hello guys. Today our topic is about NTLM relay. As we all know, NTLM relay is an ancient exploit method. It now has many restrictions, and it needs to have a rebirth. So we will talk about some tricks to make NTLM relay great again. Yeah, NTLM relay is dead. Long live NTLM relay. And I'm Junyu, and my Twitter name is MD5Sort. I'm from Whoops CTF team, and I'm 2-year-old Jigpong winner. Jigpong is a contest in China targeting to smart life. And here is my GitHub. You can find some useful tools here. And here's my mate.
Hello, I'm Jianing. This is my Twitter. I'm from the secure security team, and this is my blog. You can find some penetration tester article on this.
And we are all from Tencent Security Xuanwu Lab, and we are web security researcher and pen tester. Okay, today we will talk about NTLM relay. We will talk about some NTLM relay basics, and then some known NTLM relay attacks. Next, we will talk about our new findings, a new way to send credentials in browsers, and a SMB reflection attack rebirth. Finally, we will talk about how to defend against NTLM relay attacks. So let's start with NTLM relay basics. What is NTLM? NTLM is called NTLM Manager. It is a protocol for authentication, integrity, and confidentiality. It is a challenge response authentication protocol. It usually has 3 messages. Type 1 message is for negotiation. Type 2 message is for challenge. And type 3 message is for authentication. In Microsoft Windows, there is an interface called Microsoft Web Security Support Provider. And it can be implemented by NTLM, which is called NTLM SSP. Okay, let's move to the 3 types of message. And type 1 message is for negotiation. The client wants to log into the server, and the client sends some basic information of itself to the server and asks for a login. And the server will return a challenge and ask for the proof of credentials of the client. So after the client gets the challenge, and it calculates with the password, with client's password and the challenge, and it will get a challenge response. The client sends the challenge response to the server, and the server checks the challenge response is right or not, and finish the authentication. And there's some protocols using NTLM SSP, such as SMB, HTTP, LDAP, and Microsoft SQL Server. So before we come to NTLM relay attacks, let's talk about Windows name resolution first. When you access a domain, the Windows will resolve the domain to an IP address. So it obeys the following order. First, it will look up the name from the host file. And next, it will perform a DNS query. If not found, it will look up the local LLM host file. And if also missed, it will use LLMNR and NBNS, these 2 protocols, to get a real IP. So what is LLMNR? It is a link local multicast name resolution. And it is based on UDP And here is a sample packet. And NBNS, it is Net BIOS Name Service. It is typically based on UDP2, and it is a broadcast protocol. And its source and despot are both 137. And here is a sample packet. You can see the source port and despot are both 137. And there is a famous exploit called bad tunnel. And that exploit uses this feature. And NBNS and LLMR can be easily spoofed. Here is an excellent tool called Responder. We can use this tool to spoof these two protocols. So the attacker can be any host. So what after that? And there is a special host called WPAD, which means Web Proxy Auto Discovery Protocol. And by default, in the internet properties, they automatically detect proxy settings and is set to true. So the Windows will first access HTTP wpad.dat to fetch a PC file. The PC file contains some proxy rules. So, which means if the attacker can hijack WPAD, the victim will get the PC file from the attacker, and the attacker can be the proxy server. So after the attacker becomes the proxy server, the attacker can insert any HTML tags in the HTTP response. Okay. Based on this knowledge, basic knowledge, let's see a typical NTLM relay attack. What does this look like? First, the attacker wants to log into the server as victim, but the attacker doesn't know the victim's password. So the server denies the login of the attacker. And the attacker waits until the victim wants to access example.com. And it will check the WPAD first. So the victim asks, who is WPAD? And the attacker can give a fake response. And it says, I'm WPAD. You can get PC file from me. And the PC file says, the attacker is also the proxy server. So the victim believes that the attacker is the proxy server. And it asks the attacker for the response of example.com. And the attacker just hijacks the response and injects an evil payload. This evil image tag is the source points to the attacker's SAMA server. And after the victim passes the response, it will launch a request to the attacker's SMB server. Yeah, as the victim and the attacker are in the same intranet, the victim will send its credentials automatically. And the victim will perform the three-step auth login. First, the victim will send the type 1 message for negotiation to the attacker. After the attacker receives the type 1 message, it just forwards the type 1 message to the server. And the server responds with a challenge to the attacker, and the attacker just relays the challenge to the victim. And the victim calculates the challenge response and sends to the attacker. The attacker just forwards this challenge response to the server. So the victim believes the attacker is the server, and the server believes the attacker is the victim. So the attacker can log into the server successfully, and what for the victim, it just can send any response to the victim, just cut off the connection. So the attacker can log into the server as victim. And sometimes the victim and the server is the same machine. The victim sends the credentials from one protocol, and the attacker will release the credentials back to the victim. Yeah. And they may be the same machine. And let's see some real world attacks. The first one is called FMB reflect attack. When the victim accesses a UNC path or a file protocol, just like this, and the victim will send its credentials automatically. The attacker can just reflect the credentials to the victim's FMB server. And the attacker can achieve RCE while starting a service. And this attack can be performed easily. And the Microsoft released a patch called MS08068. And in this patch, it stopped FMB to FMB relay on the same machine. And years later, there comes another exploit called Hot Potato. And this exploit works on Windows 7. This exploit first starts a web server on the local host and binds on port 80. And it will hijack WPAD and redirect Windows Defender update to the web server. The web server will ask for 401 NTLM authentication and will relay the credentials to the local FMB server. So the Hot Potato exploit can log into local FMB as system. So this exploit can be used as a privilege allocation. And it relays credentials from HTTP to the FMB on the same machine. And Microsoft released another patch called MS16075. In this patch, it fixed relay credentials from a local HTTP to local FMB server. So there comes the question, is NTLM really dead? Here, the answer is no. We can still release credentials to another machine. We can relay from FMB to Microsoft Exchange Server. Because Exchange Web Service supports NTLM authentication. And there are many useful web APIs. And we can even achieve RCE via a vulnerable Outlook client. So if you have an old version of Outlook, you may be attacked. Your computer may be compromised. And we can still relay FMB to another machine's FMB. As long as the two machines share the same credentials. And here we have a demo. The first demo will relay credentials to a Microsoft Exchange server. We use these tools here, a responder. A responder is used for spoof Windows name resolution and NTLM relay to EWS. This tool is used for relay credentials to Exchange server. And we just start these two tools and see the video. And we will start this. We will check the Outlook client. It works. And we will start these two tools. And the weak team opens Chrome, just opens Chrome and close it. And after we open the Outlook again, we can see a calculator is popped up. And another demo about relay credentials to another machine. And these two machines share the same credential. The Windows 7 and Windows 10. These two machines share the same credentials. We will start our tools. And use a tool called NTLM Relay X. And with SMB2 support. And the weak team access the attacker's fake semi-server. And it will sense the credentials. And we just release it. We release it to the Windows 10 and get the NTLM hash. And we can use the pass the hash attack, and we can start a calculator on the Windows 10. We just copy the NTLM hash. And here pops up the calculator. We can see the user now is administrator. Yeah. Okay, after these two demos, people may ask where to get a SMB request. We can get a SMB request from the browser, from the Word, from the PDF, from the Explorer. And the most common one is the browser. And here is a table that shows the modern browsers, whether they support WPAD or SMB. From the table, we can see only IE on Windows 7 and Chrome supports WPAD, which means the attacker can be the EVO proxy server in these two browsers. And we can say Chrome blocks the SMB access. So when we access HTTP web pages, it cannot send the credentials out automatically because it blocks it. So we cannot attack IE or Edge on Windows 10 remotely without the user interaction, because the attacker cannot be proxy server and he cannot insert a EVO tag. So if you want to attack these two browsers, the victim needs to browse attacker's page. And we cannot attack Chrome remotely because Chrome blocks requests to the SMB server. Because we are not allowed to load local resource. And we cannot reflect credentials to SMB on the same machine because of these two patches. So let's ask this question again. Is NTLM relay dead? The answer is almost. And NTLM relay needs a rebirth.
Okay, just now my mate has gave us an introduction to the various way of using an NTLM relay attack. We can also see well it. Microsoft has also provided many patches to against it. So the NTLM relay attacks really died. After our research, we brought new hope to these dying patients. As mentioned earlier, NTLM SSP can be used to complete NTLM authentication for the various servers. Here I will introduce NTLM authentication based on HTTP. Now that we are talking about HTTP servers, the browsers are a typical that has to be mentioned. Various web browser has implemented the NTLM authentication themselves, but they are also different in implementation of each browser. I will introduce those differences one by one. Okay, let's take a look at what NTLM authentication over the HTTP. First, the browser accesses the web page that needs NTLM authentication. After receiving the request, the server checks if the HTTP handler contains the authentication information. If it doesn't, it returns the 4.1 Studio's code and pop the user that they are not authenticated. After the browser received it, it finds the page needs NTLM authentication. So the browser will take the first step. NTLM SSP negotiation is also called type 1 message. After the server receiving the type 1 message from the browser, it returns NTLM SSP challenge. It's also called type 2 message. And when the browser gets the challenge, it will hash it with the user's credentials and generate type 3 message. After the server receives the type 3 message, it will use the same amount to calculate a hash. Server will compare the hash, if it is the same. NTLM authentication will complete and the resource is returned. So how to send Windows credentials automatically in browser? This is an interesting question. Open the IE settings. We can see as follow: the automatic log only in the internet. After a machine is joined a domain, when IE access a non-FQDN host name, it will make the DNS query its first. For example, if the domain name is the Tencent.com and the host name is the file server, DNS require what is the file server.tencent.com IP address. If the HTTP port of this host needs NTLM authentication, it will also be automatically authenticated. So if the is the internet environment, Windows suppose some ways to check whether the URL is a internet zone. There are two API help us to determine whether the URL is internet. The first is the process URL action, and the other one is the map URL to zone. So, what is about the policy and the zone? There are many types of policy has been provided by the Microsoft, but now I will mention the two here. The first one is the URL policy credentials silent login OK. Another one is the URL policy credentials master prod users. The second one, which means prod the user to enter the username and the password. Generally, in the second policy, whether the user really should really to be reminded by the pop box depends on the value of the zone. Looking at this table, at least the different means represented by the different values and whether the user would automatically log in. For example, if you enter URL, the policy is URL credentials master prompt user, but the zone value is 1, which also automatically logs in. Based on the two APIs, we run a program for testing and found different features on the Windows 7 and Windows 10. The network environment we test on working group environment. Why would we choose the working group environment? Because in an enterprise intranet, there are generally two environments. One is the working group environment, and another one is the domain environment. When the browser encounters the hostname type address in domain environment, it automatically adds the current domain name to the host name, and it determines all non-FQDN types address as a local internet zone. Because the domain environment is a trusted environment, but it's not the same. But it's not the same in the working group environment, which is less secure environment. So we can see this table. If you on Windows 10, you type the Windows 10 in the URL, the policy will be URL policy credentials conditional format, and the zone value is 1. But in Windows 7, the value is 3. They are different. So the browser how to implement this feature. And the Chrome and the Firefox both use the function called they can use default credentials, which the function returns true. It will automatically log. When the returning first, the user is reminded to enter the username and the password. But the Chrome is respecting the Internet Explorer setting. But the Firefox depends on the user setting. If you want to automatically log in, you need to open the about config and then set this value to true. So now we can do attack Chrome remotely because the Chrome will automatically send credential in the internet zone is over the HTTP. Another interesting is the amazing Chrome Omni box. And then the test environment is also in workgroup environment, and the Windows 10 and the Chrome 17. If a victim type anything in Chrome mini box, such as Today News, and then the Windows will ask who is Today News through the name resolution. Attacker can answer it by the spoofing. I'm the Today News and need you to complete over HTTP NTLM authentication. And then the Chrome determines the Today News is an internet zone, so it will automatically log. After that, the attacker can obtains the credentials and then relays it to the other machine. So can we relay the credentials to the same machine? The SMB reflection attacks rebirth. SMB credentials reflection attack was discovered 10 years ago, and the Microsoft fixed within the MSF 08068 patch. In 2014, James Foshel put forward a cross-protect NTLM relay attack. What I'm introduced today is to use the same of the feature of the Java to complete this attack. James found that the way attacks are used for local privilege escalation, and our way is can do RCE. The operation is divided into the following 5 steps. The first one is the using attack. The victim uses the Java application to access the web page, which needs NTLM authentication. And then the attacker can stain the net NTLM hash from the victim. After staining the net NTLM hash, attack can reflect the net NTLM hash to the victim sample servers. Now it's the same machine. Because the net NTLM hash from the victim, so the net NTLM hash is correct. It's correct. And then the authentication will be successfully. At last, the attacker can do RCE while starting a remote service. When can Java send HTTP request? When a Java application has a SSRF or XXE vulnerability, it can issue HTTP request. In the SSRF vulnerability, only HTTP request sent through the JDK build class named HTTP URL connection. It will automatically complete the net NTLM authentication. When exploiting the XME vulnerability, you can defend intended to port the URI. And the XML processor will choose the way of connection according to the protocol, and will automatically use HTTP URI connection to send HTTP request. Through those 2 attacker surface, we can get net NTLM hash. So, white Java can automatically NTLM authentication. When the request is sent by the HTTP URL connection, the request is actually sent out while the write request. And then the user returns the full Wang authentication after receiving the request. The previous request process doesn't end. Some function in the HTTP URL connection find that the server needs NTLM authentication, and then it will call the get server authentication function, and it returns the authentication object which contains the authentication information. There are very important field in this get server authentication function. This field is the transparent NTLM server. If this field is always true, the username and password will be picked up from the current logged on user credentials automatically. The process of defining a transparent NTM server is two-step process. The first step is the determined by the support transparent as in the NTM authentication process. And another one is the is trusted state. We can see this code. This function is always returned true. So the transparent NTM server is always true on the Windows. So let's take a look at the process of SMB credential reflection attack. Attack is the HTTP server that requires the NTM authentication, and the victim is the machine that provides the SMB services. It can be a server or PC because the SMB services is provided by default on the Windows. The victim sends the request packet as shown in the picture, which the first step in the NTM authentication. Some flags are set in the negotiate flags field, and the current computer name and operating system version are also provided. The information is encoded by the base60 info and set in the authorization field in the HTTP handler. After the attack receives the victim NTM SSP negotiation, it does the same thing with the victim's SMB services. But this time is the NTM SSB negotiation over the SMB. The victim returns the NTLM challenging to the attacker. The attacker doesn't immediately generate type 3 message after receiving the challenge, but instead of restores the challenge. We need to pay attention to the negotiated flags at this time is the AC. The attack will return the challenge abandoned in the previous step in the NTM authentication over the HTTP. In this step, attack not only transferred NTLM challenge, but also modified the negotiated flags. Please pay attention to the picture. The type 2 message returned by the attacker at this time. The negotiated flags become the A0. Why modify those flags? Negotiated flags changed from the AC to A0. We know that the binary of the C is the 1100. We change 2 bits. Both of them are changed from 1 to 0. So they are a flag from the setting to unsetting. There are 2 flags. The first is always sign, and the next one is the 004. Why we need to change the bits? Because we don't know the signature, so we only need to unsend it. Another ones we need to spoof it. Server and client are not on the same machine. After victim receives the challenge sent by the attack, it will use the create NTM hash to perform the net NTM hash on this challenge. And then it will send the net NTM hash to the attacker. This is a NTM authentication of the HTTP. The attack will forward the net NTM hash to the victim SMB servers, completing the process of forwarding the victim own credentials to the victim. After the SMB is authenticated by the attacker. Some servers are started by using TCE or RPC to RCE. So this victim has been pawned. So let's see a real world case. I found a XXE vulnerability in the Apache product some times ago. I can use this XXE to complement the RCE with the attack vector we mentioned earlier. This project is for the database design, and the configuration format is the XML. If the product opens the crafted configuration file, it will lead to XXE. In Java, XXE vulnerability, we usually use it to read files and line services, but those are a limit. We know we have talked about it, but the talk is cheap. I will show me the shell. I will show the demo for the SMB credential attack. Okay, this attack around the tools. It's named the intro relay. We will release the tools. This is a crafted configuration file, and use the product to open it, and then we got the NTLM hash. We can use the pass hash to RCE. Okay, the calculator is popped up. So, how to defend against the NTLM relay? For the client side, I suggest that disable automatically logging in internet when the environment is the group environment, and then disable the WPAD. You also can block the TCP 139 while the file fault. If you don't provide the SMB server, you can block the 445 port. For the server side, you can enable the SMB sign, but the SMB sign is enabled by default on domain control. If you are not domain control, you need to enable it by yourself. Another is for the Exchange web servers. I suggest that the Exchange web server should be built on the internet. If the Exchange web servers is not used, you can disable access to it. Here is our material reference. And I want the special thank to the Tom Keeper and the Flower Code. During our research, they have gave us many useful advice. There are also a lot of the always the tools to help me complete this research. The impact and respond and the NTLM relay to EWS. Okay, thank you for your attention. This is our tools. We release it. Is any questions?
You mentioned in your talk that you're modifying the flags of the negotiate message.
Yeah.
How are you doing that without breaking the signature that's on these messages?
Because we set the sign flag to 0, so we don't need a sign.
Yes, but if you look at the Wireshark in the next message,
yeah,
there's the one after, I think, the third message.
You mean in the type?
I mean the MIC. If you see the type 3 message.
Type 3 message?
Yes. Yes, on the bottom you see a MIC, which is a signature based on all 3 the messages. And as far as I know, if you change any flags, then this signature will be invalid and it won't work. But that was not your experience, or how did you solve this?
We may not understand the question properly. Can we talk in private? So sorry for that.
你需要我翻译吗？
可以。
他就是说，你换了那个 flag， 那个 signature 就换了。他就问你，你们有没有面对这个问题吗？如果有面对的话，你们如何去解决？
就如果有 sign 的话，应该怎么解决是吧？
没有。So you're saying that when the flags change, the signature should be invalid, right? 他就是说，如果 flag 有换了 ，signature 就
if the flag is not changed, the process will be cut off. We cannot perform such attack. So if we want to perform this attack, we need to change this flag.
OK， 他讲他等一下跟你们All right, I think that's all the questions we have. Thank you, Wang, Jianing, and Zhou Junyu for the talk.
Thank you.